Welcome to Allegedly Does Not Replicate, a podcast by the Institute for Replication, where we put research to the test again. In today's episode, we'll talk to Anna Drever about open science initiatives. Hello, everyone, and welcome back to the podcast. Today, we have a very, very special guest, Professor Anna Drever from the Stockholm School of Economics. Hopefully I didn't butcher that with my accent. Thank you so much. I practiced it. And we're going to have like a very, very interesting conversation. Professor, why don't you introduce yourself and tell us all about not only what you do, but also what we're going to be talking about.
Okay, so introducing myself, I don't know what to say. Well, I should be prepared. Well, okay, we can cut lots of stuff. But okay, I don't know. Say this. No, I'm Anna. No, but I'm a professor of economics, but I mainly work in meta science. What do? I do lots of different things, so I can't really summarize it. But for the last few years, I've been doing things related to replications, reproducibility, predicting replication outcomes, predicting scientific tests, and sort of thinking about hypothesis testing in general. In economics, and, as an economist, you can do anything, right?
Oh, of course. Like we like to jump into each other's, like into other disciplines, terrains, and I think we love it, but I don't know if other disciplines might agree with that. So,
but I think experimental is especially the case. It's a small community. And I think, each time I talk to people like in psychology or in health and so on, they mention the study we're going to talk about, and they mention many different things, but I think they think that economists are doing lots of lab experiments and online experiments. And I'm always surprised. I'm like, no, not really. It's actually really small field within our discipline. Most people use non-experimental data, but when you talk to other people, they have this impression, I feel like, that we're doing lots of lab experiments like psychologists. So I think it's natural, like, that within this community, you have to start talking to psychologists, you have to start talking and being interested in other fields, which I find really interesting.
I mean, I agree. And even before I was doing sort of meta science work, I was very much into reading papers in psychology and other fields and would publish in such journals to some extent too. So there was already that communication. But now with the meta science work, I think that lots of what's interesting, in particular for experiments, is not happening in economics, but happening in other fields. And I think we have a lot to learn from, say, psychology. And economists often have this take that we have so much to teach everyone else, but I think we do have a lot to learn as well.
For sure. I think from psychology, especially everything related to replication and reproduction. I mean, some of the conversation and papers sometimes that I refer in economics, I'm like, come on, like in psychology, they've done this 15 years ago. Like they don't have the same theoretical model or whatever, but this argument has been done like a long time ago. And I feel the conversations are way more pushed and nuanced and sometimes interesting than what we have in our own discipline.
Do you think that happened or that was fostered within psychology just because they had the most visible replication crisis? Or do you think something else managed to brew like that within the field of psychology?
Yeah, good question. I think large chunks of it is probably because of this sort of clear visibility of the replication crisis. And that's probably also related to the methods, like experiments can be replicated. And by replication, I mean getting, like you can actually redo the experiment with new data and see to what extent you can get similar results. I mean, lots of economics, psychology, sociology, political science, etc. It's hard to get new data. So it's hard to really put original tests for, to test them like that. Whereas for psychology, that can happen. So I think, the methods is part of it. And then depending on who you talk to, I think many people will have started thinking about replication based on having read some paper that they just found ludicrous or something. And then that triggers something. So I think if you talk to many psychologists, they will discuss this ESP paper by Daryl Bem, like extrasensory perception, published in a top psychology journal in the early 2010s. Many people do not believe in extrasensory perception. And scientific evidence is close to zero. So how can they find statistically significant results suggesting extrasensory perception and publish this in a top journal? I think that was like a aha moment for many people. That was not my aha moment, but I think many people would raise that. That's a combination. Sorry?
What was yours?
I think I had a mix of stuff, including sort of some of my own false positive results. that was not the aha moment. I wish it had been earlier, but it was more like, okay, wait a minute, over many years, I'm wasting lots of time, money, and energy. So I was, like, as a PhD student, interested in individual variation in risk taking. And I looked at sort of social norms and gender norms related to risk taking, but also biological factors like hormones and genes. So I did a study with collaborators looking at testosterone risk taking. In the same experiment, we also looked at dopamine receptor genes and risk taking. So, dopamine is a reward system in the brain. So you could think that that's related to how economists think about risk taking too. So we ran an experiment with about 100 men. We have a DNA sample of these guys and we genotype them for 2 specific dopamine receptor genes. And we report both results in the paper. And we find that one of the 2 genes is statistically significantly linked to risk taking and the other is not. And we reported no results, and the significant results survives multiple testing correction. And I was super excited about this. I was like, wow, there's this genetic basis of risk taking that fits also with sort of what we know from twin studies and other.
Sure.
But at the end of the day, and the day was like many years later, I realized like we had basically no statistical power whatsoever in that study, extremely likely to be a false positive result. We did study after study digging deeper into this and had a harder time finding something, of course, because the original result was probably a false positive.
Yeah.
But at the end of the day, I wasted so much time, money, and energy on something that was extremely likely to have just been noise in the first place. So I really fooled myself. And of course, I've semi-fooled others too, because others have cited the paper. So that was sort of one of my aha moments. And then the other one is related to power posing. Another sort of top psychology paper published in 2010, which suggested that super tiny interventions in how you sit or stand, basically whether you stand in an expansive or contractive pose, will affect hormones and behaviors and feelings. And I mean, maybe this tells you something about my sort of very naive priors. I read the paper in 2010. I was like, wow, this is amazing.
But I heard about like studies like this in the news.
And there was like a huge TED talk about it.
There is this huge TED talk, and it's the 3rd most viewed TED talk and has more than 75 million views. Keeps on increasing. I mean, last time I checked, it had 49 million views, and then a couple of years later, 75. But when I read the paper came first, and then the TED talk. I thought like, okay, given my interest in risk-taking, hormones, and gender differences, what if we make women power pose and we close the gender gap in risk-taking or something? So we set out to like extend the original study, replicate and extend. We were not out to get power posing in any way. And by we, I mean mainly my collaborator Eva Ranhill and a team of researchers, Roberto Weber, Magnus Johannesson, and others. We were not out to get it, but to see whether we could extend it. So we basically did very similar study, some changes that we believed sort of would only benefit power posing, and we made it experimental blind. And we did a data collection, we meaning Eva, did a data collection with 5 times the sample size. So instead of 42 participants, we have 200 participants and basically find nothing. So that was surprising to me in the sense that I had actually believed in power posing, and we managed to publish that paper in 2015. So for me, lots of things were happening in that time period, 2010 to 2015, and I think for many others too. And at the same time, you had these papers like the false positive psychology paper by Simmons et al., the paper by John et al., looking at how researchers self-report questionable research practices, etc. And then earlier work like John Ioannidis, why most published findings are false, etc. Lots of things were happening at the same time that led me being a bit more skeptical about published findings, including my own. So I'm the first one to say that there are results of my own that I'm now a bit worried about.
Oh,
Professor, this is so interesting because like it's very rare to talk to someone with that level of self-awareness of what's going on. Normally, like we fool ourselves, like trying to think that our paper works and our results are of course not false positive but true results. Like, how do you come to this level of self-awareness? It's actually very impressive to talk to someone that is also critical of her own work in to such degree and has such awareness of her own like a possible false positives. It's super interesting.
And now before you jump in, I just want to say that I think a lot of people in your situation, what they would have done is just dig deeper. and deeper. And I think a lot of people who have these false positive convince themselves.
Exactly.
Let's go, like, I need to do a follow-up work. It didn't work with 50 observations. Let's go like again 50 more and 50 more. And at one point you just,
Well,
fish and you just keep going down like that route, because if you have like this seminal paper that comes up with like this new thing of like the pause or whatever, you just want to keep going with this.
or
And,
you would just start doing subsample analysis until you find something.
But been there, done that. I mean, I'm guilty of that too. I was digging deeper, collecting more data. And this was, I mean, for the genetic stuff, this was at the time when that was expensive. So that was really like, it took some time to realize that it was a waste of resources. But so I made those mistakes. But at some point, I think most people would update. So
but it's interesting because to me, like when I think of how expensive it is to collect an extra data point, I usually think that it's much harder to PIAC, whatever that means, recollecting data or playing with the data or dropping like whatever observations, like I just find it's much harder. But I think, your point also is, which is a bit the other way around, is, yeah, but you don't have power. And because you don't have statistical power, you might have like false positive, and it's going to be incredibly difficult to tell whether you have anything like this because you cannot keep collecting data. Or maybe you're going to stop collecting data as soon as maybe you find an effect, just because you're like, well, we found the effect that we knew was there. We'll just stop there. It's crazy expensive. So I see like a lot of tension personally when I think of like sample size. I believe studies that spend a lot of money on each data point. I do more genuinely, just because I think it's much harder to actually, shake the data or whatever. But there's this tension with power. So I like your point of view of like, this thing of power is actually incredibly important. And when this field keeps moving and we can like generate more data and so on with like MRIs or whatever, or genetics, etc., then there's many results that now, like, we realize they were false positive. But I think for me, like a small sample doesn't necessarily mean I don't buy it. I just want to know like how expensive that data point was and how hard it was to actually manipulate it and to drop it. So I like this tension.
But I guess, I mean, at least in economics, 10, 15 years ago, when it comes to experiments, there was very little discussion about power.
Yeah.
And now there is way more, and I think that's very positive. But at the time, a sample of 100, why not? I mean, we had no real, at least I had no feeling for power at the time. And many of us, I think, had that take like, oh, if you find something with statistically significant in a small sample, that's a good indication of what you would find in a large sample, which is obviously wrong, right?
Sorry.
No, go for it.
No, it's very interesting because I think that the understanding of a statistical power as very important has not penetrated so deep in other subfields that do not do experiments. So for example, when you do observational data, I have seen people run things with 30, 50 observations. And the rationale is very interesting because they never think about false positives. Their only concern is false negatives. And as soon as they get something, as you said, they're happy with it because in their minds, they got over the false negative threshold and they found an effect, which it's very hard to explain to people that power not only drives false negatives, but also false positives. And in other subfields is wild.
And I think that speaks to the beginning of the conversation where, to me, like when I think of experimental economics, I really think of like a small group of people in different parts of the world doing their thing and completely not like segregation or whatever, but there's really discussions happening in that specific subfield of economics that just do not happen elsewhere. And I think it's fascinating. And to me, like, I remember seeing all these studies on like, these retractions or false positive and psychology a bit in experimental economics. And I remember like when you did this paper with Colin Kammerer, like Felix, many different people. So the title for people interested. So this was published years ago in Science, Evaluating Replicability of Lab Experiments in Economics. When this came out, to me, was sort of a shock, like that came out of nowhere. And it's so interesting that for you, it was more just like natural. There were tons of things happening, like even back in 2005 with John Ioannidis and many others. Like to me, an applied microeconomist interested also in political science, like it just came out completely out of nowhere. I was interested in p hacking and things like this back in like 2010 when the expression didn't even exist. But the idea that you could do replication or that, you would find replication rates of like 50% came out completely out of nowhere. So I'd be super curious, like, how did this project like come about? Like for you, it seems to be like natural that you would do this, but I think for most people listening and in sociology, political science, economics, and so on, it's just projects like this are quite unique. And the scale, it was just like really impressive. So if you can talk about this, I think would be super.
Yeah, but I mean, the big psychology project, Open Science Collaboration 2015, is way cooler and more impressive. I like what we've done, but it really sort of builds on what others have done. So it's not like we are changing everything, but very much inspired by the big psychology project, we decided to try to do something for experimental economics. But this started not really from the replication side. It started more by, there was a profile of Brian Nosek in Science, I think it was like in early 2012 or something, profile of the whole Open Science Collaboration project. And together with colleagues here, we had been talking about prediction markets and having like prediction markets on scientific outcomes, asking researchers to bet on outcomes. And I think this also stems from like earlier years when we were reading papers and thinking, okay, this is a very cool and cute result, but it's almost too cute to be true. And we were discussing, it would be fun to see whether other researchers agree with this assessment, and like, what if we would have them bet on this? And my husband, Johan Almenberg, and our close friend Thomas Pfeiffer, who's a computational biologist, were very interested in prediction markets. So we had those conversations repeatedly. And then I read about this big replication project, and I was like, this might be our chance to do, have prediction markets and replication outcomes. So we contact Brian Nosek and basically say like, hey, we're a bunch of economists plus a computer scientist and a computational biologist. Can we collaborate on prediction markets on your replications and on your group's replications? And he said, why not? Let's see whether someone minds. And if not, then sure. Which I think was amazing how he basically just encouraged us to do this and like enabled us to do this with him. So at the end of the day, we ran prediction markets at two different times, one in 2012 and one in 2014. That became our first sort of prediction market on scientific outcomes paper. Mm. And when we had run the first round of prediction markets in 2012, I met Colin Cameron maybe a year or two later at the conference on Sicily, where I presented those results a bit informally. I think I was there to talk about like hormones and decision making, but I was more interested in the prediction market stuff. So I included a few slides on that in the conference anyway. And we talked, and he was very enthusiastic, and we discussed the then big psychology project that was still work in progress, and said, let's try to do something related in economics. So that's basically how we started that project together with colleagues here and elsewhere. We basically contacted other groups that we had worked with and decided to try to do something more small.
Yeah. That, like, how do you collaborate with so many labs and so many people? And not only in this project, but in general, like you've got projects now on Mechanical Turk and many different replications. It just like looking from the outside before I started the Institute, at least, I just thought like, what a nightmare this must be to coordinate so many labs, so many studies, and trying to get the original authors to help you because, you know, now let's say on Prolifix or whatever, like you need some information, like at least, you know, what the experiments look like and things like this. So like, how do you deal with the scale, and like, what are sort of the protocols or things you've learned over time that you're like, I'm never doing this again, or I would do it differently?
I think my job is easier than yours, to be honest. So it's not that complicated in the sense we're not that many people involved. So like the first Cameron et al. Paper. So Magnus Johannesson and I had talked about something, and then I talked to Colin, and we said, okay, who are other experimentalists in economics that we think would be interested in this that we have worked with, basically. So we had a few teams who we were like enthusiastic about and had a track record with. And then they sort of increase their group or bring in PhD students, postdocs, and we all work together. And sort of there is some division of labor. And I think that applies to almost all of these projects. And in particular, maybe in the ones where we also have psychologists who I think are maybe better at creating some division of labor, actually, who does what. So everyone is not giving input and everything at the same time. So I think that has worked out quite well in these projects. We try to communicate with authors, as you say. And of course, I realized that when I send an email, it's easier that people ignore it than when Colin Kammerer sends it. We can use that to get...
It makes a huge difference. Like I remember sending emails to people before I started the Institute to get data and codes. And people would know, like would, email back, like, sure, Belle, here's some codes. But the people wouldn't know, like, which is most people in my discipline would never respond back. The second I started the Institute, people would look at the website and the board and everything is like right away, here's the data, here's the code, here's everything. What else do you need? And it was just like so surprising. So having Colin or anyone like on board like this, I'm sure makes a huge difference. It's sad. It's really, really sad, I find. But being like a PhD student or someone just like assistant prof just starting, trying to get like replication package from someone like in the 2010, forget it. Like it was so hard, and some authors are really generous and like, would do it, but the vast majority would just ignore your email. So I can sympathize with that.
But I remember, the experimental economics replication project, I think almost everyone replied immediately. I think everyone actually replied fairly immediately. So that's maybe because it was in this experimental economics community already sort of situated. Whereas when you start expanding to other fields, I guess it's easier to be ignored. That said, most people do actually reply, but there have been like a few examples of where really I write and just ignored.
So what do you find? 50%? Like, what does that mean? This 50% that was in the news all the time back then, and even like on, some TV shows and things like this, and things don't replicate in psychology and lab experiment in economics. Like, what does that mean, 50% for people?
I mean, depending on the project, we're somewhere between 1/3 and 2/3 of results replicating. So maybe 50% is
the ballpark. Yeah.
Plus minus something. That's, so I sort of, that's what you get when you aggregate these numbers. At the same time, I think you have to sort of think about the power of the replications in the sense of what statistical power did they have? And some of the replications, had the intention of having high power, 90% power to detect 100% of the original effect size. That sounds great if you don't think original effect sizes are inflated. If you think even true positive results tend to be inflated when they're first published, okay, then you might be underpowered. There are power issues, I think, in some of these projects. And
let's stay back for people who don't understand statistical power. And I would say it's like most people in general, like even people with like PhD and so, like people have no understanding of what you're talking about here. And so usually the original study you would hope would be powered at, let's say, 80%. That's sort of a norm that has been developed in medical science, things like this. And you would hope that, but that's not always the case, especially back then, people were not doing statistical power. So they find an effect, it's statistically significant at 10%, and now you're using new data and you're thinking, okay, what's the sample size we should have? And what always strikes me is you're not going with the same sample size as the original authors. You're being very nice, if you want my opinion, by going with a larger sample size. And what you're trying to think is, because I think most of the experiments that you do with new data is with larger sample size most of the time. Would you agree with that? Or
yeah, but that's what we get from the power calculation. So even if you do this sort of simple power calculation, 90% power to detect the full original effect size, you typically end up with the larger sample size than the original one. But that's, of course, a function of like the original effect size and the original p-value. Yeah. So the lower the p-value, the sort of, the smaller sample you need. So when original studies are published, there are many reasons to believe that even for true positive results, they will have something exaggerated in terms of the effect. So there's this very nice paper by Andrew Gelman and John Carlin from 2015, sort of discussing what they call type M and type S errors, where M is for magnitude and S is for sign. So conditional on having a statistically significant result. As a function of power, how exaggerated is your effect size? And how likely is it that the true effect is actually the opposite direction of what you observe? So this type M error, like how exaggerated your effect is that I mean, your effect will always be exaggerated, basically. And then it's, of course, worse the lower power you have. And then this type S error, which I think is a complete nightmare to end up with. You think you have something, and maybe you want to go to policymakers or whatever, and the true result is in the opposite direction of what you have. I mean, what a nightmare. So that's a type S error, and that becomes a problem when you have very low power, like less than 20%. And as a side note, then there's a very interesting paper by John Ioannidis and co-authors in Economic Journal a few years ago, where they look at power in economics.
This is the most depressing paper I've ever read. And I've refereed like follow-ups and so on. This is so depressing. Go for it for the punchline, but
median power is low. We should be worrying
and
about
the mean is low. Everything is low.
Yeah.
I think in a follow-up, they find that status quo power, we should have like John or Tom Stanley was on the pod, but like the median or mean status quo power for articles recently published in top 5 journals in economics, those that most economists would say, is something like 5%. It's so shocking. It's so bad that I remember like sending an email to Tom. I was like, how can this even be? Like it's much higher actually when you go down the ranking of journals. But anyway, like we're moving on a tangent here.
So I mean, so power is a problem.
It is a problem.
If sort of, and that should apply to, I think, many types of studies. So when we think about replications of experiments, 90% power to detect 100% of the original effect size sounded good. But now if we think that even true positive results are exaggerated, then we have to take that into account. So in a follow-up of this first Kammer et al. Paper, we decided to replicate social science experiments published in Nature and Science in the time period 2010 to 2015. I mean, that was a sort of a natural follow-up to what we had already done. And then we decided to do potentially a 2-stage procedure in data collection where we increase power. So we do a first round of data collection where we have 90% power to detect 75% of the original effect size. So even there, we allow original effect sizes to be inflated, and we are better powered to find them then. And then if the result does not replicate according to sort of a binary definition of replication, we do a second round of data collection so that we have 90% power to detect 50% of the original effect size. So this leads to sample sizes that are about 4 times as big as if we were going for 90% power to detect 100% of the original effect size. And then we can see sort of what do we learn from increasing the sample like this. And at the end of the day, now I wish I could afford to do like 90% power to detect 50% of the original effect size for every replication, which is not the case. So we typically go for like 90% power to detect 2/3 of the original effect size.
And so are the replication rate increasing when you're doing this?
Yeah, so a couple of more studies replicate.
Yeah.
So in that sense, the some of the earlier work, like in these replication projects, was probably underpowered. But then, I mean, there was lots of early work that was not underpowered, I think. Yeah. And I was not involved in those. And those are the so-called many labs projects in psychology, where instead of just replicating one result in one lab, they replicate several results in several labs at the same time. So power is way less of an issue in those projects.
So, like, what do you make of, like, 33% to 66%? Let's say that's like, a 50% on average replication rate, or let's say maybe it's 60%. What do you make of that? Like, so just for people, like, there's many indicators. It could be like it needs to remain significant at 5% and the same sign, but there's many different indicators. And at the end of the day, they all, give you something close to like, 50%, let's say. Isn't that like depressing?
And I wanted to ask, like, do you think that's moving in which direction? Do you think we're getting better, or do you think?
Yes. Oh. I think we're getting a lot better. So I think things are improving dramatically. I think they have improved dramatically in psychology, and it's sort of spilling over to related disciplines. I think experimental economics, I would think that replication rates have improved. They were higher, though the number of replication was smaller in that project, so it's a little bit unfair to compare, and inclusion criteria were different. But I would guess that it has improved everywhere. And so it's a little bit unfair that experiments in economics and psychology, etc., have received so much sort of attention and bad press. The beauty of experiments is one of the many beautiful things about experiments is that they can be replicated, right? Mm-hmm. I do a study, Abel or Juan, you can redo it. I mean,
that's fair.
We can discuss how close is the replication, but you can typically redo these and get new data and see, do we get similar results? There's so many other things where we cannot assess replicability in that way for good reasons, because there is a policy experiment or whatever that is just not repeatable and we still want to understand it. But that is, I think, is one reason for why we are talking so much about replication crisis and experiments, because we can assess it. I think I have learned from my mistakes and mistakes of others. I still think I have more to learn, but there are also sort of, I think as disciplines, we have also learned quite a lot. And I would bet on sort of replication rates having improved.
I'll play the devil's advocate.
Oh, yeah, go for it.
I think, the bad press for psychology and lab experiments in economics, like 50% is bad. Like it is really, really bad when you think about it, because we're talking of studies that are most cited or at very least published in the best journals. We're talking about what should be, in theory, studies that are peer-reviewed by some of the best referees, by the best editors, that we're expecting really something really truly amazing. And yet half of them don't replicate with new data when you follow the exact same protocol. And I think if you would say this for, work being done with data, but like observational data to someone, I think most people would not think that it would be something close to 50%. I think but back then,
given this low power, if whatever median or average power is not this is 5%, aren't you even more worried about results?
I'm saying back in 2010, let's say 2015, before we had studies that look at power, before we had like mass reproductions happening, studies that showed that things are not robust. Like we were in a world where there was no comments ever almost being published. People were not sharing their data and codes. It was incredibly hard to just reproduce someone else's work. So I think the bad press that experiments in psychology got was because, well, yeah, we can show that things are actually really bad. And we cannot necessarily test whether it's bad or not for observational data. So I would say, looking back at what was happening, I think it's somewhat a bit okay that, psychology and experimental economics really received like bad press, just because that was the data that was coming out. And I think if you would ask me, like, do I trust more an experimental study than non-experimental nowadays, I would say no. To me, they're both of them on average, I would say maybe I believe like 2/3 of studies that I see. And whether it's an experiment or not, I would say doesn't matter too much. RCTs, I would believe them maybe a bit more than lab experiments and non-observational data.
Why? But I think they're costlier or?
Costlier, yeah. To me, cost really matters. And I know you can fudge the data. I know you can.
Aren't you more worried about the incentives for p-hacking? If you've done something super costly, you really should find something.
Yeah, that's fair. But if it costs you $50,000 to do this experiment, probably you had to write a pre-analysis plan. Now it's not necessarily posted anywhere, but someone gave you the money. So you had to actually think about that stuff. You had to think about statistical power. You had to think about lots of different things. And it's so expensive, and it's an RCT, and it's probably somewhat unique. You will be able to publish a null. And I think I remember like when I was collecting the data for Star Wars, we couldn't find a paper that was a null. Like we read like 500 papers, and there was only a couple of papers. I remember reading the abstract and it was a null. They were all RCTs, all of them, done in India or Sub-Saharan Africa, Kenya, basically. To me, it was just shocking. It was like, wow, if you do an RCT and you spend so much years of your life on this project and you find nothing, they will publish it. You will be able to publish this. And the authors will want to publish it because they just spent $50,000, tons of RA's time and years. You will want to publish. I think the cost of not publishing it is so high that I think authors also have a larger incentives to do it. Whereas if I put this in comparison to like, and I know it's unfair, but like an MTurk study in marketing with like 77 observations, and they pay them like 20 cents each, I'm like, I don't know. What are we doing here? You can clearly, why 77? Why that number? Like, I've read hundreds of these studies in marketing and like, business journals and so on, and there's no justification for sample size. There's no statistical power discussion. And I'm just like, how many times did you run this experiment? You say you've done a pilot, at least you're honest about that. But like, did you run this thing like 70 times? You pay them like peanuts. So there's no cost. So for me, it's really hard to believe a study like this.
I agree with this. I mean, that was at some point my biggest concern with like online platforms, that it was so cheap to do studies. Okay, now you show me one result or from one study. How many studies led up to this particular one?
Yes. Mm-hmm. But you're doing a mass replication of studies using MTurk. So for people who don't know MTurk, so Amazon Mechanical Turk is a platform. It's like an online labor market, and researchers use this a lot to do surveys and online experiments. And basically you have people and, you can ask them to answer questions and you can randomize them. So it became this huge tool in 2010 and it became crazy popular because before when you were doing experiments, you had to buy pizza and hoping that the undergrads would show up to your lab at your university. And maybe you would pay them, but usually often it would be the pizza and the reason why they would show up. But it was really hard to collect data. And now you have this new tool, this Amazon marketplace, where you just go and you can collect observations like this. It keeps going and keeps going. And it's so easy. And I think this led to just a change in the way people were doing experiment. The cost of collecting an additional data point is so small that you could think that people might actually run this thing until it actually works. So I think you and I started thinking about these problems at the same time. So I wrote a paper more about like p-hacking, publication bias, but I think your project is way more interesting. You're actually replicating these studies that use MTurk. And I don't know if it's released or publicly available. Or
not yet, but hopefully soon.
So how many studies are you replicating?
26 studies.
They're all using MTurk, published in some specific...
Also using MTurk, published in a specific journal, specific time period. And this is also related to sort of the interest in prediction markets. I mean, and coming back, because we use the so-called decision markets in order to decide which studies to replicate. So decision markets function similar to prediction markets in the sense that participants are incentivized to really sort of state their beliefs about prediction, about replication probability, but then we basically let market prices decide how to move forward. So decide which studies to replicate. So we had a list of 41 studies that we could potentially replicate. We told participants that we will for sure pick the 12 studies with the highest prices. We'll for sure pick the 12 studies with the lowest prices. So these are the 12 plus 12 studies that the markets think have the highest and lowest probability of replicating. And then we're picking 2 random studies among the rest of studies. And the payoffs are scaled according to the probability of being picked for replication, so that everything is incentive compatible. So that's, I think, in a world where there are so many replications to be run, I think that's an interesting thing to test. And you could use other, maybe more interesting decision rules. But coming back to the question about sort of how positive or negative is 50%, or let's be more generous, 2/3 of results replicating. Well, I guess one thing that has made me more positive, or thinking there is a positive spin to it, is that when we use prediction markets or surveys and ask researchers to predict replication outcomes, they are pretty good at it. And that suggests that there is something systematic about this, and maybe we already know to some extent which results replicate, and maybe I think that makes the problem less severe, but maybe that's the optimist in me. I just also feel like the fact that these replication projects have been done have led to some changes that have been positive. So I think things are improving, and that's just sort of, that has happened in a fairly short amount of time. Norms and practices have changed, I think, for the better in many ways. There are still tons of discussions, as you know, about the usefulness of pre-analysis plans, but at least we're having those discussions. And I can see sort of, yeah, if you do a super theory-driven experiment in economics, maybe the need for a pre-analysis plan is weaker than if you do a new power posing experiment, if that had not been done before, you know. So I guess it boils down to sort of what's the prior probability of the hypothesis being true, which I think we should try to incorporate more when we assess research and think about new studies.
Professor, I think I have a question. When we talk about experimental economics, there's a very real possibility that the experiment is going to be replicated for like someone like you going out in the wild and replicating studies. But when we start seeing observational studies that are very low powered and are based on natural experiments or stuff like that, it's just gonna happen once in a lifetime. For example, Abel's paper on mass shootings, like we cannot just go on and randomize mass shootings in the wild, right? Fortunately, right? But some of these studies are very underpowered. How much should we trust those papers and the policy implications and the learnings that we get from those papers? Because there's a bunch of people that say weak evidence is better than no evidence at all. And listening to you talk and listening, for example, to the power posing paper that made a huge splash in the literature, and now we have like a huge community of people believing a result that is false. I don't actually know if that's true. I don't know if the risk of learning something that is untrue is outweigh the benefits of not doing the thing at all in the first place. So I wanted to ask, how much should we trust those, and should we scrutinize way more those papers with low power that tackle these huge questions with observational data?
Yeah, I'm not sure what I would do here. I mean, we should maybe be more Bayesian about this and not put that much sort of weight to that one specific individual paper, sort of, which is very much against how we live in academia, where we are our papers. We all push for our individual papers, which is not necessarily healthy. I mean, it's part of a larger discussion. You can say something about the literature at some point. I don't know. I mean, I think you can learn a lot from individual papers, but at the end of the day, you need to do some not formal meta-analysis necessarily, and then think about, of course, publication bias and these issues when if you only see positive results and there are good reasons to believe that there are no results out there. Okay, that is very problematic. So I think for such studies where you cannot have a credible pre-analysis plan, you cannot replicate with new data, etc., there are still many things one can do. And I mean, Abel has thought about this way more than I have, so you should ask him this question, so he should answer it. But at the same time, you can do things like a multiverse analysis or specification curve. You can do more than a few robustness tests. You can basically try to set up the universe of tests and run them all and show the distribution of results of effect sizes, color-coded for significance or something. So you really show everything. I mean, taking robustness to the extreme. This has also been receiving a lot more interest in like psychology, political science, economics, statistics during the last few years. And it's related to things that have been already discussions that have been going on in economics for a long time. And go back to Ed Leamer's Let's Take the Con Out of Econometrics paper, and you would see many of these ideas there. So I think it's interesting that now sort of is obviously a good time to discuss these issues because many people care.
It just took 50 years for us to start doing this. But I find it interesting, like you're hinting at something which is, you know, individual studies are often like, you know, cited a lot, and people, when they see a new study, they like to believe the result, or maybe it fits their priors, or maybe they're overreacting to seeing one study. Personally, I don't believe a study until I've seen at least another study finding exactly the same thing. I'm quite conservative, if you will, about this. But I think, do you think it has something to do also about like journal rankings? About people being completely obsessed about studies published in a subset of journals? Political science would be like top 4, economics top 5, and even the idea that we have these things of top 4, top 5 is, some people say it's just wrong in a sense. But do you think it has something to do with publishers, with journals, with just the structures in general that we have in academia. And like a lot of people now are saying, let's get rid of all this and have journals like +1 and these, more life cycle of like a project that other people would jump in on the project, reanalyze the data, and it just becomes more open. Do you believe in these things, or are you more thinking the system, it just needs a couple of small tweaks and we're good to go?
I think at least we should try some small tweaks before we do something more radical. But we differ here in different fields. I mean, in economics, as you say, we care a lot about specific journals, and in other fields there is less focus on specific journals, maybe for the better. So I don't know of any papers in economics that do the following exercise, but there are at least two for psychology papers where they look at basically how papers are cited depending on whether the results successfully versus unsuccessfully replicate. So based on all these replication projects, these authors, and one is Felix Schaffmeister, who was a PhD student here, and another paper is by Marta Serra Garcia and Nuri Gnisi, where they basically look at citations of the original studies a few years later. And does it matter whether the results successfully versus unsuccessfully replicated in these replication projects? And the results basically suggest that, if anything, unsuccessful papers or results, those papers are cited more. And Felix finds that they're cited about the same. They have slightly different samples.
Yeah, in economics, it's been done with comments. So we had Jörg Peters who talked about this. And so, but with replication, I don't think so. But I've seen a couple of papers now on looking at.
Yeah, I mean, I think there's more to think here. And there have been ideas by like Lucas Kaufman and Muir Niederle, where they should make, like, if you cite an original study, you should also cite replications. And if you do that, maybe you realize only that the original study reported that result and replications didn't. Okay, the story becomes a little bit more complex. I think that's probably good.
Yes.
So we should take that more seriously. I'm also a big fan of registered reports. So registered reports, maybe everyone knows what it is, maybe not. But these are like pre-analysis plans with an introduction and motivation, etc. Sort of like a normal paper, but there are no results. And why? Because the data has not yet been collected. So this is sent out for review. Reviewers get a chance to say something about the design and motivation. Is this interesting? Do the analysis make sense, etc.? And having that reviewed, if the outcome is eventually positive, the journal commits to publishing the paper no matter what the actual results are. And I think this is sort of a way to put emphasis on what I think are the most interesting things, like what is the contribution? Are these interesting hypotheses? Do these analyses make sense? Are the measures good, etc.? And not be blinded by, oh, what a huge effect or whatever. No results, not surprising, not interesting. Let's forget about it. Like register reports, and obviously that's going to work well for experiments. And
but I was going to ask for this. I think, would you be open, or do you think it makes sense also for non-experimental work that you have the results, you've actually never presented it, you've done everything, but it's not public, and you submit to the journal without the results?
So the problem is, I think, credibility there. If I get such a paper, and I know the authors have the data, I would guess that they have no results. So that's why they want to go through this process.
In order to change that equilibrium, you need to start accepting those, right?
Yeah, but I mean,
you're going to be stuck in this equilibrium where you're never going to be able to trust these registered reports because only null results are being submitted. And I think the referees would take this into account or not. If the design is good, you think the contribution is good, why do you care if they find an effect or not?
No, but I think if everyone expects the results to be no results, because otherwise you wouldn't have written up that paper. It's almost like you read the no results paper, and then you probably get that no result penalty already in the review round. So for experiments, and there are non-experimental types of data for which you could write a credible
admin data, things like that. Sure.
Registered report. So there, I think, we should embrace it to a larger extent. And we talked earlier about the RCTs and sort of costly development econ studies. Journal of Development Economics has had this type of track for a long time. And I think that's fantastic and great in so many ways. So we can learn within economics too from other fields.
Have you published so you're a co-editor at Journal of Political Economy and Microeconomics? And you have the register report. Have you published any register reports?
Not yet, and hopefully soon. I mean, we haven't had that many submissions, but just recently we've had a few. So
Okay.
we're getting
Because I think Journal of Development Economics, I remember seeing a presentation at BITS of one of the co-editor, and he was explaining at the very beginning they didn't have that many submissions, but the submissions that were going through and that were conditionally accepted were those by more senior researchers. Just because I think the referees felt more confident that this RCT would make sense, that it would be implemented properly, or that the researchers sort of knew what they were doing. Whereas I think for more risky projects and juniors, it's kind of harder to read this and say, yeah, but I don't have the results, so I don't really know what's going to happen. To me, that was one of the problems early on that I was told with register reports. It's a bit unfair for juniors or for ideas that are a bit more risky. And I don't know what are your thoughts on this, or whether
it's really too early and I don't have enough data to say much. But so far, I'm not sure that that's been the problem. I feel like it's been more the complaint of the register reports that we've had so far, or the submissions, have basically been about like, are these interesting? Are these hypotheses interesting enough?
Yeah.
Or like, are they too specialized? Almost all reports have actually been very positive to the register report component. And I've been like, yeah, I think it's fantastic to have a register report and it's a well-written paper. Reviews have been very positive, but then the folks has been like, maybe this is just not that interesting, which is bad too. But
it's interesting as a comment.
Yeah, review, and I think that's because the focus is all about, is this really like an interesting design, an important contribution, and well-designed study, sort of.
Yeah, why not use to write refer reports?
Sorry.
Like that. Yeah, I think it just, when you write a refer report, to some extent, I think some people, and I've received like my share of rejections, hundreds, but I think many referees go over the paper and are trying to find ways to kill the paper. And that's how they sort of write their refer report, in a way of just, so when there's no result, it sort of becomes like, well, I don't know what they're going to find. So the critique becomes more about like, I don't know if this is going to be interesting because I don't see what they're going to find, and I don't know which type of mechanisms they're going to be able to explore. And I don't know if it's
in those comments. It's been more like, okay, this is placed in a literature where there are already many papers on the topic. So while this looks interesting, well designed, maybe it should be in a more specialized journal. I mean, that's a summary of the most common comment. Is that a fair comment? Sometimes yes. And then
I think we're at time, but I'm sure we're gonna have you at some other point, because this type of conversations are just fascinating, and we love to talk to you. But before we go, I wanted to say thank you so much for having us, and thank you for taking the time.
Thank you.
Any final comments that you or Abel might have?
No, I think we've covered everything. But thank you, Anna, and yes, I hope that you're going to be back.
Yeah, I hope so too. Awesome.
Thank you so much.
Thanks.
Bye bye.
Thanks, everyone.